Hello everyone and welcome to yet another recreation programming session with Mr. Zozin. So I think this is already a third time I'm trying to document the development of this feature. Yeah, I think it's the third time. And every time I try to do that, there's some problems that make the session kind of boring to watch because I encounter something and I just get caught up in debugging and stuff like that. So essentially, this is Visualizer, right? So we're working on a Visualizer, which is pretty straightforward application, right? So you drag and drop some music in there and it starts playing the music and it starts visualizing that specific music. And this is not a music player or video player or anything like that. It's meant to actually render videos, high quality videos of the visualization so you can then post them on social media. Right, but here is an interesting thing. I didn't really want the, the visualization of the files to be the primary feature. One of the important things for this application, I think, is an ability to capture sounds from microphone and from the system sounds, so you don't have to record anything yourself, so it will record it for you. Right, we already can kind of integrate with the microphone in this application, and that feature is by default is disabled. It's behind a so-called feature flag, so to be able to use it we first have to enable it, right? So let's actually go to the configuration and let's enable visualize a microphone, right, and rebuild the whole application. Should be pretty fast, right? So it doesn't require rebuilding Raylib or anything like that. So it's actually started, and now you have to press C, and as you can see, we can now visualize things from the microphone. We can't really record anything from the microphone, but we can visualize things from the microphone. So the interesting thing about that feature is that to implement that, we kind of had to poke a hole in an abstraction of Raylib. Right, so let me actually show you what I mean. So if you take a look at the Raylib is the library that we use for UI and for sounds as well. It's a library for making video games, right? And video games, they are concerned with the visual part and the sound as well. That's why this library is extremely useful for us. And I also recommend to check out this library if you're doing game development and, generally multimedia application development. It's also cross-platform. It works on all of the major operating systems, right? So, and if we take a look at the architecture of this library, it has a very cool and interesting architecture. Right, so essentially at the top you have your game, right? So you have your game, you have an engine, whatever. And the library itself consists of several modules that are kind of like, replaceable. You can turn off some modules and stuff like that. So the main modules are core. Probably you can't disable that one. Right, so the R core is basically the camera, the window and stuff like that. Is just like, creating the actual GUI application. So here you have stuff working with textures. Here you have stuff working with text. Here you have stuff working with shapes, models. And this one is interesting one. Here is the module for working with sound. Right, and it is based on a different library, on another library called Mini Audio. Mini Audio is also a very cool library. It's a single header. It's a single header library for working with audios, and look at all of the platforms it supports. Right, it supports all of them, basically, right? So all of the major mainstream platforms, including Android. So that's actually very cool. And this library does have a capability of working with microphones, and that's the capability we use, but Raylib doesn't. Raylib doesn't. So essentially what we had to do, we had to use Mini Audio library from Raylib, but we had to bypass the abstraction of Raylib and work with Mini Audio directly. So we kind of poked a hole in this entire thing. And it works great so far. So as you can see, if you just run this application, it is totally fine, right? So it seems to be working. So the problems start to appear when you try to record the stuff that you receive from the microphone. So and it's a very interesting problem, and this is the problem that we struggled in the previous stream. that I don't plan to actually upload to YouTube because like I just was debugging this thing for the entirety of the stream, so I didn't think it is that particularly interesting to watch. So yeah, it's still on Twitch if you want to watch it, right? So, but I mean, it's really not that interesting, trust me. So this documentation has a bunch of examples on how to record the audio. So let's actually find the captcha. Where is the captcha? I can't I can't spell captcha. Captcha. There we go. Finally, I managed to spell captcha. Right. So here is a very simple example that does the capturing. So let's create captcha. C. There we go. So essentially here we are including mini audio. So then we are creating two important things. We're creating a device from which we are capturing the sound, and we're creating the encoder that is going to encode the sound. And what we're going to be using, the wave encoder, right? So we're going to be creating the wave file. So the first thing this example does, it creates the wave encoder. Right, it creates a wave encoder. Then it initializes the device with the same parameters as the encoder, because I mean, yeah, they have to have the same parameters to be compatible with each other. Right, and then we start in the device, right? And as we initialize the device, we also provide a pointer to a callback that basically takes the frame it captured from the device and sends them into the encoder. And that's basically the process of recording. You get the data from your device and you send it to an encoder. An encoder encodes it and probably sends it to a file. And as far as I know, do we provide the file? Yeah, we do provide file through command line arguments. And there we go. Here we initialize the encoder. And we provide arg1, so basically whatever we got from the command line in here. So, and that example works. That example works perfectly. We can even test it out. So let me go ahead and try to compile that. Obviously, it's not going to compile, but I'm compiling it anyway, so I can get an errors, right? So there we go. So here's an error. It cannot find MIDI audio. So I think what we have to do, we have to provide the include. So I do have MIDI audio in raylib source code. So it's somewhere here, src, and I think it's in external. Yeah, there we go. So it must be in external. Okay, so it is compiling the things. The mini audio library, by the way, is rather huge. It is rather huge, so it takes some time to compile this entire stuff. So it complains about the lack of mathematical functions. So let's go ahead and just link with mathematical functions. And that should be it, I think. I think that should be it. Yeah. There we go. So, and we got a captcha executable file. So if we try to now run it, it wants a file. So let's actually provide recording wave, and that should start recording. That should start recording. So, and everything I say right now should be recorded into the file. So now I can try to kill this entire process, and it should create the recording wave file. So let's actually open it up with and that should start recording. That should start recording. So, and everything I say right now should be recorded into the file. So now, so as you can see, it works flawlessly. It works perfectly. So the problem starts to appear when you try to integrate that example into Visualizer itself without almost no changes whatsoever. It's rather a bizarre problem, right? And it's when we spent like 2 hours figuring out what the fuck is going on. So yeah, it's rather interesting, and it has kind of like a philosophical implications about you know, using third-party dependencies and how much control you must have you know, over those third-party dependencies. But I digress. Let's actually go and try to integrate this simple example into Visualizer. Right, so I factored out a start capture function. Right, there we go. So here it is. And in here, we're just initializing the device, simply initializing the device, and go into the capturing mode, right? Go into the capturing mode, and in the capturing mode, we're already visualizing, doing the things and stuff like that. So the simplest integration would be to basically also add the encoder. Let's go ahead and do that. So the state of the application is located within the plug. So let's try to add the encoder as well. I'm gonna just grab the example and find my encoder. Where is the ma encoder? So there you go, ma encoder, encoder. There we go. So that's pretty cool. That's pretty cool. So start capture. So here we're starting capture. So let's actually think what we want to initialize first. So in this example, we're initializing the encoder first. So we might as well actually do that here too. So let me copy paste this line, which is going to create a config encoder, right? So its type is this. So let me put it like that. And as you can see here in this example, they first initialize the variables and only then use the variables. Probably they're trying to be compatible with C89. Right, so we're not using C89, so we can initialize, we can declare the variables wherever we want. It doesn't really matter for us at all. So the next thing we have to do, we have to initialize the encoder. So this just creates a config structure, right? It's just a configuration, but it's not an encoder itself. So then we have to initialize the encoder. So let's provide some sort of a file here. So recording wave, maybe I'm going to factor it out to recording a file path, right? Something like that. Const char recording file path. I'm going to put it in here. And then we're going to log the errors. So we already have a logging mechanism in Relic. We can just use trace log. This is going to be log error. And in here we're going to say fail to initialize output file. That's not a bad description of what happened. We might as well even say what exactly is the file that we're trying to initialize. So it's going to be a recording file path. And as far as I know, you can also specify the reason. So the way you report the reason, there should be a function. Yeah, there we go. My result description. From the initializer, we get the result. We must be getting the result, and we can transform that result into the description of what exactly happened. But as you can see, we're kind of throwing away the result. So I think it would be nice to maybe just put that result somewhere here, right? So first saving the result. If it's not the success, we are reporting an error. And another thing we're doing here, we probably simply return. Right, we probably simply return. And since we're in a capturing mode, right, but microphone was never successfully initialized, microphone is not working, the capture state is going to basically show an error. So everything should be fine, I think everything should be fine. So we initialize the recorder, everything's fine. Excuse me. And here we're basically using the same parameters as the encoder. Excuse me. And as far as I know here, what we'll do in the example, we're literally copying the parameters from the encoder. I think it's a good idea. So if you change the parameters, you don't have to change it in two places. You only have to change it in one place. So in that case, I think it's a good idea to just like copy the parameters from the encoder. I think it's a good idea. So there could be some problem in here when we failed to initialize the device. So we have initialized the encoder. So that probably means we have to de-initialize the device. Right, or maybe the encoder, I mean. So essentially, if we manage to initialize the encoder, but device has failed, we report an error, right? So as you can see, we actually prefix these things with mini audio. Maybe this is something that we want to do here as well, because it's kind of like a convention in this area of code, right? So we uninitialize the encoder, right? And in here, if we do that, we uninitialize the encoder as well. It would be nice to maybe put all of that into some sort of like a defer section, but it doesn't really matter, to be fair. None of that really matters. So here, when we start the recording, now we should be also saving that into the file. Not only visualizing, but also saving that into the file. Right, so let me try to recompile this entire thing. So it's going to be nope, and let's go and see what is going on. Right, so let's go to the compilation errors. So the encoder must be this one. Right, I forgot to put this prefix in here. So what's the next error? The next error is a semicolon. What's the next one? Yeah, all of these encoders, they are part of the plugin system, so we can do it like that. And there you go. That should be working. That should be working. So if I now try to run this entire thing and then start the microphone, I couldn't do anything. Right, which is kind of bizarre. And if we take a look at the error log, it says mini audio failed to initialize output file recording wave, no backhand. And That is such a bizarre thing. It's literally the same. We're using the same code, yet it doesn't work. So, and on the Twitch stream, we spent quite some time figuring out like what the fuck is going on. And we got to the point where, okay, let's just take the original example. Let's just take the original example and link it with the raylib. The original example works. We can confirm that. So let me actually demonstrate you. So I think I forgot to build it. Yeah, I removed the executable. So let's actually rebuild the executable. Let's wait a little bit. And let's do captcha, recording, wave. So the original example works. We can confirm that. So recording. So the original example works. We can confirm that. So it does in fact work. That's pretty cool. But whatever we have in Mutualizer, it simply doesn't work. And the only difference between these two examples, we figured it was a raylib. So there must be something with the raylib. So let's go ahead and just take this example that we got from Mini Audio and link with raylib. Literally, just literally link with the raylib, like so. And by the way, don't use Mini Audio implementations. So the way this thing works, right? Essentially, raylib already includes Mini Audio implementations into itself. It already includes it. And Mini Audio is a header-only library. So that means it acts like a header when you include it. And it doesn't include any implementations. So to make it include implementations, you have to define this macro. As soon as you define this macro, it starts to act like a C file rather than a header file, right? So its behavior depends on the lack of presence of this specific macro, and it is done intentionally so you can control where implementations go. And for instance, if you link in with a library that already includes the implementations, you probably don't want to include that macro. So because it's going to be taking the implementation of these declarations from a completely different place, right? So that's basically how header-only library works, STB-style header-only libraries. Right, okay, so let's actually link with raylib. And as far as I know, we don't even have to do anything particularly special, right? So it cannot find raylib, so let's actually add to the include path raylib 5.0 src. So now it should be able to find raylib. Right, it couldn't find assert. So let me actually remove this entire thing. And there we go. So it cannot find the implementations of these functions. That is totally fine because you have to link with raylib. Can you see Scheiße in this mist minor front? I don't think you can, but yeah, there we go. So what I'm trying to do, I'm trying to link with the lib raylib.a. And it cannot find that, right? So let's provide the path where it can find those things. So it can find them in the build somewhere because I have them pre-built. You still can't find it because it's multi-line thing. Just a second. Doing everything for you, my friend. Doing everything for you so we can see what I'm doing. So here it is, and there we go. So it cannot find mathematical functions, and I suppose this is because the flags do matter. The order of flags does matter, and there we go. All right, so if I try to now use the captcha recording, right, it doesn't work. Nothing changed. Literally nothing changed, except we're not using the default implementations of Mini Audio that come with Mini Audio that also comes with raylib, by the way. We're using the Mini Audio from the raylib source code. So the only thing changed is that we're linking now with the raylib. This is absolutely bizarre problem, and I never expected that I'm going to encounter that. But yeah, it cannot start this thing if you're using implementations from the raylib library, even though we're using the same Mini Audio. What the hell is going on? Anyways, so we figured it out. If you go ahead and look into the source code of raylib, you'll find something very interesting. So specifically our audio, right? So because we're using our audio module, our audio.c. So it obviously includes Mini Audio. It obviously includes Mini Audio. Somewhere there should be an include that just includes Mini Audio. There we go. It does in fact include Mini Audio. If you look around, you will find something interesting. If we go into the external dependencies and into the MIDI audio in here. So disable the built-in wave encoder and decoder. So when RayLeap includes MIDI audio into itself, it disables the MIDI audio's ability to work with WAV files. Why does it do that? Because it is using a different, and this is my hypothesis by the way, I don't know for sure, but I think this is because it uses a different library for encoding wave. So I suppose Raysan just didn't want to include two different implementations of the same things, right? Or maybe it's, maybe they have the same, wait a second, I think DrWave and MIDI audio are created literally by the same person. Yeah, they are created by the same person, so it's probably even literally the same thing. It is probably literally the same thing. So yeah, that's very interesting. So if now you go into the R audio and just remove that, just comment that out, and rebuild everything from scratch. So we probably want to not really rebuild everything from scratch, but rebuild at least RayLeap. Right, so let's actually do knob. So let's wait a little bit. Rebuilding everything. P-poll. P-poll. So I'm gonna drink my tea, I suppose, while it is building itself. I'm drinking actually green tea today. People like to keep asking me about what kind of tea I'm drinking. I'm drinking actually both kinds of tea, green one and black one. I just change them from time to time. So if you now try to do that, it just works. It just works. It just works. So yeah, speaking of why it is important to have control over your dependencies, because of these kind of situations. And I'm not dissing on RayLeap or Raysan. RayLeap is an extremely cool library, and it would, whatever I'm doing would not be even possible without it, right? So because it's just a collection of ready-to-use things, and you can just even copy-paste it into your project, and that's literally what I did, and just like use it as your own code, right? So you can sort of like modify things as you want, and everything. So it's just incredibly cool, right? So what I feel like is happening is that we're slowly growing out of abstraction called R audio, right? The first sort of flag, the first sort of hint that R audio is not the thing that we want to use was probably when we had to use MIDI audio directly to work with the microphone. Right, because this is a library created for making video games, and we're trying to be like, you know, we want to have a lot of flexibility on the audio side. So, and now we have this kind of thing. So now we found that our audio actually configures MIDI audio with the parameters that we don't really want. So what I'm thinking is that the time has come for us to drop our audio and just work entirely directly with MIDI audio. And that's another cool thing with RayLeap. So it is split into these sort of like a semi-independent modules that you are not obligated to use. Actually, you're not obligated to use. For example, we kind of grew out of the R audio, but it doesn't mean we have to stop using RayLeap. We can just continue using our core. We can just continue using our text and all of these things. We just don't link with our audio, and it is independent from the rest of the things. Right, so we can just start using MIDI audio, and yeah, that's actually very cool. That's actually very cool. So RayLeap is like an abstraction, but it's sort of like a terrible abstraction. It does not try to hide things from you. So yeah, that's a very cool thing, is that RayLeap is trying to abstract things away from you, but it also realizes that abstractions leak. So it doesn't try to hide things from you. It allows you, okay, so it doesn't work for you, just tear it off and use the thing behind this thing like directly. So it's really interesting. It is really interesting. So it's sort of like a multi-layered library that is easy to pick up. It has ready-to-use solutions, But then if you want to go deeper, it still allows you to do that, right? It's just like, it's so cool. It's so really well designed. Anyways, so since we know what the fuck is going on, right? So I would like to kind of finish that feature. So essentially, if I now run the visualizer, so I probably want to actually start it from here. So, and I try to record something. Right, I suppose that kind of worked out. Right, and if I go in here, I can't hear shit in this mist. I know why. Because even though I managed to initialize the encoder, I didn't really send the frames, the data that I received from the microphone into the encoder, right? So it's probably happened somewhere in a callback. So there we go, we have a callback. And in that callback, I have to call to the capture.c, right? So not capture.c, but I have to call to this function that I can find in the capture.c. Right, so what essentially it does, it takes the encoder, right? Our encoder is located somewhere in here, and it's pointer, right? So we have to take the pointer. So the input here is buffer data, right? So it is the parameter from here, and the amount of things is the frames. So then we also set the fourth parameter to null. I have no idea what that is, but this is something that we must do. So let's actually try to rebuild this entire thing. Yes, and I'm going to try to run visualizer. So let's try to record something. And I think it didn't stop recording things. I'm pretty sure it didn't stop recording things. So let's actually listen. I think, okay, so it did in fact stop recording things. So the reason why I thought it didn't stop recording things, because in the capture screen, when you are currently capturing, it always goes into this function capture screen. And so in here, when we stop recording, it only uninitializes the microphone, but it does not uninitialize the encoder. So I thought maybe it continues recording. Right, so maybe that's what happened. I don't really know. But one of the things we probably have to do, we have to ma encoder uninit. So, and then we have to do something like encoder. There we go. So that's definitely something that we have to do. All right, so, and if I recompile everything, right? So let's recompile everything. It should be working. So after we recorded the file must be added to the track list, right? So the file must be added to the track list the same way as you add the file when you drag and drop and it crashes actually. Why the fuck did it crash? What the, wait. What? Loaded successfully and it didn't even crash, it just quit. Without explaining anything. So it didn't even say segfold or anything like that. Welcome to C, I suppose. Why does the fucking exit? Oh, wait a second. So let me try to run it in the in here, visualize it in the compiler mode, because it usually shows the exit code. So we can kind of, it's segfolded. Okay, so that's cool. That actually segfolded. That is very interesting. But the cool, people are really scared of segfolds, but the cool thing about segfolds is that you can at least know where they happen, right? So if you use the debugger, so if I go to here, right, so let's actually do that and run this entire thing. So that should start this stuff. I don't really know what, and okay, so that's segfolded, that's cool. So let's see, oh yeah, okay, so we're calling to the encoder when we don't have the encoder initialized, obviously. Duh, you dummy dum-dum. So call back. You only want to do that when you are in the capture mode, I suppose, right? So capturing. So that's the only moment when you want to do that. Otherwise, just don't do that, please. That makes a lot of sense. Yeah, that's the power of the debugger. Again, people are afraid of segfaults, but they actually tell you that your application is just touching the memory in the places that it's not supposed to touch, and the debugger quite often can tell you where exactly your program is touching the memory in inappropriate places. Cheers. Don't be afraid of segfaults. Don't be afraid of segfaults. Be afraid of, I don't know, stack corruption, right? So because that shit is truly scary. And if you just dereference a null, it's like it's not a problem, right? So you can always figure out where exactly that shit's happening. Anyways, so yesu. So essentially, as already said, when we finish the recording, we need to add the file. Did I not recompile my Scheiße, meine Freunde? I think I forgot to recompile my Scheiße. It's segfaulted again. Freaking goddamn C. Why am I still programming this language 2024? There we go. So it should be added like this into the track list or something. Okay, how can we do that? How can we do that? So let's go to capture screen. Right, capture screen. So this is where we stop doing the things, right? And how do we add the track when we drop in the file, right? So the file is dropped. We load in the music. Then we check that it loaded correctly, and so on and so forth. So that's pretty straightforward. That's pretty straightforward. So we're using file path. We should probably use the recording path. So recording file path. There you go. I can copy paste it. Though I feel like the name should be sort of like procedurally generated. So essentially, by default, it's recording. But then if you record another file and it sees that recording.wave already exists, it should try to use recording 01. And if that exists, 02, 03, 04, and so on and so forth, right? So it will just basically create more different recordings, and then you can delete them if you don't want them, right? So they should be on the file system. So we're gonna load that as a music, recording file path. Then we are touching all of these things and everything. Then we are kind of cloning so we can manage it separately, right? So I'm doing str_dupe. I don't really know why, it's not really needed in here, but maybe in the future when we implement deleting the tracks from the track list, we're going to be freeing those strings, and because of that it's better that these things are located like in heap, not in a static memory like in here. But I don't know, like I'm kind of thinking that maybe for this kind of strings I'm going to introduce an entire arena, right? So then you can spam these strings and clean them up later. But I mean, we'll see. I'm still thinking about this kind of stuff. So I'm adding this thing like that. But now I also have to activate that music if it's not activated, if the track list was initially empty. So let me find how do you do that. So essentially, if no track is currently playing, and we have some tracks in the track list, we have to set the track that we just added, as the one that we want to play, I suppose. Actually, here we're setting the first one as the one that we want to play, but I mean, it doesn't really matter. So I think it has to be behind this condition. So every time we do recording, we're just like adding this thing. All right, looks good, looks Gucci, looks Tamaguchi. So now let's do knob. And let's try to record something. Okay, so I can't hear that because my headphones are there. So let me listen to that. Okay. So that's pretty cool. And now I can try to go ahead and render this entire thing into a video. So that's going to be the supposed use case, of visualizer, right? You record from microphone or from the system sounds, and then you render a video out of that. So let me actually take a look at the video. So it's output MP4. Pretty cool. So yeah, that's basically the feature that I wanted to implement for quite some time, but it's not really that cool of a feature. So I think an ability to maybe capture from the system sounds is even cooler than the microphone, right? Because for instance, you want to capture like a small clip out of the YouTube video, right? So right now the only way you can do that is by somehow like ripping it off of the YouTube using YouTube downloader or something like that, and it's just like it's really inconvenient. It would be better if this thing could capture from the system sounds like directly. You can capture a small clip out of the YouTube and then just visualize it and just maybe upload somewhere and get DMCA'd and banned from the social media, because welcome to the modern internet in 2024. Anyways, so I do not approve of piracy and copyright violation, right? So only do that when you have the permission of the original author to do these kind of things, okay? So cheers. DMCA. Anyway, I wonder if we can try to use the device that is basically the system sound. I think I saw that stuff in the examples. So there is simple loopback, but I'm not really sure what the fuck is loopback, right, in the terminology of sound. So I suppose maybe loopback is the system sound. So this example simply captures data from your default playback device until you press enter. I suppose, yeah, so basically from the sound, the output is saved to the file specified in the command line. Loopback mode is when you record audio that is played from a given speaker. It is only supported on WAS API, but can be used indirectly with Pulse Audio by choosing the appropriate loopback device after enumeration. Ooh, yeah. So WAS API, if I remember correctly, is a Windows thing, right? So it's for the video game operating system. Okay, so we do support the niche video game operating system, so that would be useful for that. But I really want to test it out with the Pulse Audio. So the question is, what the fuck is enumeration? Let me see if I do something like a power control, right? So I have some all output devices in here, so I can't really see anything useful. But what if I will open the recording and MPV? So let's actually go here somewhere. Okay, so I'm gonna make it loop and I'm gonna take a look. Okay, so there is a playback. So there is a playback from MPV. Right, there is a playback from MPV, and maybe this device is going to appear in the enumeration if we try to enumerate this kind of stuff. Right, so that would be kind of interesting. I want to kind of try that, I want to kind of try that. So, but before we do that, let me go ahead and maybe commit all of that. Ooh, we need to also think how we're going to be, having the support for Wave. How are we going to be having the support for Wave? Since Okay, here is the thing. Since DrWave is developed by the same person as Mini Audio, maybe it has literally the same interface. And what we should be doing, we should be using DrWave instead, Mini Audio. So let's actually find out. So maybe I just go ahead and open up this thing, DrWave. All right. So. Okay, you initialize the file. So first you create DrWave structure, right? Here we do that on a stack. Okay, then we are initializing it. And then we create, so this is the decoder. I don't really want to decode, I want to encode, right? So I want to encode. If I want to quickly read, so you can include this file and other parts of program as you would the other header file. Do something like this, the following: read audio. Don't want to read, I want to write. This example above, read. Okay, can also use to output wave files. This does not directly support compressed formats. To use this, look at DrWave init, right? Okay, so you have the data format, right? So you specify the container, you specify the format, so bits per pixel and stuff like that. But we're using like a float format or something. And then you just write into these things. It's very similar to what we have in you know, in mini audio. It is very similar, so except the bits per pixel. But here is an interesting thing. So we're probably converting that stuff directly, right? We're probably converting that stuff directly. So let me find PCM bits per pixel. Bits per pixel. How can I say that I'm going to use floats? The bits per sample will be set to something like 16, 24, and so on and so forth. I have a strong feeling that maybe mini audio or Raylib actually convert automatically to, like, from float to 16 bits. I think they do that. I feel like they do that. So you know what I want to do? I want to go to plug.c and find my encoder write PCM frames, and in the mini audio I want to find the implementation of this function. Show me the implementation of this function. What does it call to? It calls to on write PCM frame. Okay, so it probably like dispatches to something. Right, so there's a little bit of a polymorphism in here. So on write PCM frames wave, right? So there's this function, the internal mod doctor. Oh, okay, it literally includes its own thing in there. Holy shit! Wait, it includes DrWave as part of this, right? DrWave. Oh, and I remember when we asked Ray-san why did he disable Wave, he said that DrWave and whatever is within mini audio are the same thing. They're literally the same thing, because again, they're created by the same person. All right. So yeah, we'll need to think how to use that thing directly, because the main problem that kind of like bothers me is that so format, so what was the F32? Right, so when I say in the encoder ma format F32, I'm using floats, but in the example in DrWave, I couldn't see the floats F32. Well, you can quickly open, yeah, so open file and read PCM frames F32. So how do you do F32? Disable built-in options, disable conversion. So you can write, so init write, so then you write PCM frames, right, but can you write them as F32? No, you can't. So you can read them, as F32 or something like that, but you can't really write them as F32, so there is no really a conversion for that. Oh my god. Oh my god. My god. So, all right. Let me make a small break. Right, I'm gonna refill my cup of tea, and we're gonna think about how to like use DrWave directly instead of mini audio and whatever, right? So we definitely need to get rid of our audio module dependency, right? Because it just complicates everything. Because obviously I just want to use all of these good libraries directly. Obviously this is what I want to do. But now we have to go through the hoops of our audio. But to get rid of our audio, I have to also get rid of all of the abstractions that I use in our audio. Things like load music streams. So it has a whole mechanism of music streams that load the music lazily. So I need to figure out how to implement these mechanisms myself, or maybe come up with my own mechanism that are catered better towards the application that I'm writing. So maybe that is going to be a separate stream. So definitely that is going to be a separate stream. Anyway, so let's make a small break, and all right, I'm back with the team. So the reason why I care about all of that this much is because I don't really want to be making direct modifications to Raylib, right? Because that will just mean that my version of the Raylib that I copy pasted into the source code, of Visualizer, is going to be divergent too much from the official Raylib. And if I want to migrate, I'll have to backport all of the changes that I've made. So because of that, I don't really want to make this modification at all, and I just want to be able to work with the raylib directly. Right, so it's probably not going to be a problem once we tear down the R audio, right, and we don't use the raylib R audio anymore. But as of right now, let's just like don't do that, right? So essentially, we probably want to use DrWave directly. So let's go ahead and just do that. I'm going to go to the plug.c, right, and where is mini audio? So here is mini audio, and I suppose I want to include DrWave.h, and I probably won't be able to find that, right, because it's located in an external thing. So let me go ahead and maybe copy paste the DrWave in here, right, so we can find it. We're not going to be using the implementations from DrWave, right, but we're going to be using declarations, so that's kind of important. So it's going to take some time, because we need to rebuild our audio, because we made some modifications. And so now, instead of using the ma encoder, we must use the encoder from DrWave, right? So, and I'm not sure if I'll be able to easily do that. So encoder, do you even have an encoder? There is no an encoder. So where is the example where you do the encoding? So yeah. So p-wave, this is so bizarre, right? So here you called it just wave, but here you call it p-wave. Okay, so that's fine, I suppose. That is fine. So DrWave wave, I think that's what it was. Was it not? I forgot the name of it. It's just it without underscore. Okay. So so DrWave wave. Let's go to the compilation errors. Oh boy, oh boy, oh boy. Where is my soy? So now when we have to encode, now we'll go back to the documentation. So right, PCM frames. There we go. Finally. It's hard, man. All of these things. So we have to do p wave. We provide the pointer. I suppose if it does in fact accept the pointer. Right. So yeah. So it accepts the data as just void star. Right. So that means depending on the format, it's going to be doing different things. So input write PCM samples, return a number of PCM writes written. So that means it cannot, it may not fully write everything. Yikes, yikes, yikes. Input samples need to be in a native endian byte order on big endian architecture. This input can be converted, little endian, blah, 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 to write raw audio data without performing any conversion. So yeah, so you also do little endian, a big endian, depending on what you're trying to do. So that's fine. That is totally fine. Okay. So that's cool. So the fact that it may not write all of these samples is kind of concerning. So yeah, to do according to documentation, this thing may not write all the frames. Make sure it does. Right, so I just don't want to do it right now, but it sounds like something important because you might be losing some frames and you probably don't want to do that, right? So maybe do that in a loop until all of these samples are written or something. I think that's kind of important. So yeah, let me see. So how do we do that? So when we're initializing the encoder, we're setting up all of the formats and stuff like that. So the bits per sample is the only thing that kind of bothers me, right? That kind of bothers me because it means that we're using like a signed on or unsigned 16-bit integers, but we're using floats. Does it do the conversion with floats? With mini audio, we could have just set the format to F32 and don't think about it. Now we stripped off that abstraction. So how do you do the actual conversion? Welcome to software development. Welcome to software development. Okay, so but maybe I'm just missing some documentation, right? So maybe I'm just missing some documentation. Anyway, so let's go to the compilation errors. Let's see what's going on. So frame count. So what you don't like. What you don't like when in front of this is because I'm just using incorrect names. So here we just have frames. Here we have buffer data. We have buffer data. Let's go. Let's recompile that one more time. And what else do we have in here? So here we are initializing the file. Okay, so yeah, we need all of that stuff in here. We need all of that stuff in here. So maybe I'm gonna be doing it like that. So instead of doing this line, you can't see. Instead of doing this line, we are filling up the you know, this thing manually. So we don't even initialize it with 0. I would like to initialize it with 0. Right, so we're using like normal wave files, DrWave something, wave format PCM, any of the PCM format codes. So we have 2 channels. So we have samples bit sample rate, which is fine, and okay, so everything is Gucci, everything is Tomaguchi. So we provide this entire thing, and does it fail? Does it fail? So let's find out. So it may fail, it returns a boolean. So for initializing wave files, this holds the internal file object until draw underneath is initialized. Keep this in mind. If you're caching DrWave object because the operating system may restrict the number of files handled, application can open at given time. Sure. Okay, so what do we have in here? If you've got the result, but what is returned in case of an error? I can't see that, so it probably returns false. It probably returns false, because if all of these things were successful, it returns true. That means false indicates an error, and that's how we know that, right? If I could not initialize this entire thing, this is not what I want to be doing, right? So what I want to do, I want to just say failed to initialize the file, right? In this case, this is not MIDI audio, this is DrWave. Failed to initialize the audio. We don't know the reason why it failed, right? So do we even have mechanisms that tell us the reason? Right, so in here we just return that. I don't think we do have any mechanisms because it's just a boolean, right? It seems to be being just a boolean. Anyways, so yeah, that is basically it. So that replaces this thing. That replaces this thing. How do we uninitialize? So do we do uninit? Yeah, we do in fact do uninit. So I think that's important to keep in mind, but we just have to go through the compilation errors, right? So let's just keep going through the compilation errors. So this is p-wave that we're initializing. What's next? Right, so this is a p encoder. Aha. So this is wave, but does wave have a config? Though it doesn't really matter because we can just use these format things directly. We can just use these format things directly, but they may not correspond to the format from that thing. So format. Yeah, so it's also format in here. So getting rid of mini audio kind of makes it DrWave PCM. So format F32, my format. So it's from range from -1 to 1. What's the value of this thing? So my format, it's actually 5, right? And in DrWave, if where is the shit, bruv? Where is the shit? What is 5? There's no even 5 in here. Fuck. I hate it. I hate that. And this is created by the same person. And there is this discrepancy which makes it annoying as hell. Oof. Yikes. Yikes. Fucking yikes. I just can't. Right? I just can't. This is artificial problems. Like I'm having completely fucking artificial problems that shouldn't be there because of too many moving parts, too many dependencies. That's the why I'm advocating for having less dependencies. Strip off that crap. Strip off all of that crap. Oh, right, because you're wasting time. You're wasting time. Okay. We're gonna be stripping off that crap at some point, so we're gonna be stripping it off. But not right now. Not right now. So it's not the same as in DrWave. It's just like, I just want to save some WAV files. If only Rayleigh didn't disable that WAV mini. I'm sorry. I'm sorry. Whew. Anyways, we can take a look at maybe our audio and just see how it initializes this thing, because it probably never saves the WAV file. Maybe it does. Wait a second. It maybe does save WAV files, because I remember it had something like save WAV or whatnot. I kind of vaguely remember. So write PCM frames. So if we take a look at our audio, all right. So here is the wave. Where do you initialize that wave? Ah, here it is. I skipped through that. I didn't notice it. I didn't notice it. It's a IEEE float format when you sample sizes. Okay. And the sample size has to be 32 if you do that. Here is the funny thing, by the way, with mini audio, is that in mini audio, F32 format is equal to 5, and in DrWave it's equal to 3, and it's a library that is created by the same person, and mini audio includes DrWave. Anyway, so let's go ahead and just yeah. Oh boy. So, and here we probably have to do 32. So that means we can't just use format, right? So because they're not interchangeable, right? So here I have to explicitly say that the format is F32. So in the channels, we can probably use the channels. Okay, so I'm gonna just hardcode this stuff. I don't want to be dealing with this kind of stuff. Sorry, can't be bothered. 44,100. Right, 44,100, and that should be it. I think that should be it. So let's get rid of that. Let me recompile this entire thing. All right, so DrWave uninit, and this is not even encoder, this is just wave. So what's next? This is just wave. DrWave. Maybe it's not that bad. It's not that bad. So you kind of have to get used to the discrepancy between the things and everything. DrWave. Boom. We're good. Awaguchi, Awi Tamaguchi. Look at that. We are in fact Tamaguchi. What the fuck? Call back. All right. So yeah, everything compiled. So that means we managed to do that, I think. So let me try to now run that. Maybe it is going to work. Are you working, mother flipper? Are you recording? Please tell me. Are you working, mother flipper? Are you recording? Please tell me. Are you working, mother flipper? Are you recording? Please tell me. This is fucking funny, man. I love it. So, okay, so it's just finalizing everything. Yeah. And if you take a look at the output, where's the output? Are you working, mother flipper? Are you recording? Please tell me. It worked. We figured it out. Okay, so we figured it out. And it's too fucking funny. All right, so yeah, that's the only thing we had to do. So let me get rid of the mini audio remainings, right? So we're gonna just like remove that. I just commented them out in case they will be needed. Right. So did I? Yeah, that's a bit bizarre. So that seems to be fine. All of that seems to be fine. And perfect. I really like how it is going. So one of the things I probably want you to do, I have this pattern that any action that you can do with a shortcut, it has a corresponding icon. So as of right now, we have a recording, right, but it doesn't have a corresponding icon, right? It doesn't have a corresponding icon anywhere in here. We have a recording, right, but it doesn't. Maybe we should add that. Maybe we should add that. But since the feature is unfinished, right, so that icon should not appear when the feature flag is not enabled, right? So we have this sort of feature flag, right, that it enables or disables the microphone. By the way, let's actually see if this thing still builds when the feature flag is disabled, right? So it doesn't. Look at that. So that means here we have to do only if def mutualizer microphone and if mutualizer microphone. So that's very useful thing to do. Just try to build without the feature flag, and then we can enable the feature flag. And there we go. That should work now. Okay, so let me maybe commit whatever we have already. Let me maybe commit. So what we're gonna say, record the wave file in the capture mode, which is probably not going to be the final behavior of the feature, because I don't want to record right away. Right. First, I want to just enable the mode where you're capturing from the microphone and visualizing without recording anything. Because maybe what you want to do, you want to be able to use this as a backdrop. Who knows? Right. So maybe you want to leave it in a room in full screen, and that's going to be the visualization of what's going on in the room. You don't want to record that unless you're CIA, right? So yeah, that doesn't make any sense. So I want this to be right. I want this to be sort of like a two phases. First, you enable the visualization, only then you start recording the file, and so on and so forth. But I'm going to work that on a little bit later. So this is just basically the plans. Right. Anyway, so we need an icon for the action of capturing. So let me see. So I usually like to draw all of the icons myself. Right. So basically, I own them. But I want to find some inspiration online. So microphone icon SVG. So how you usually draw the microphone? Oh, okay. I can actually draw that myself in Inkscape, so let's go ahead and do that. Super quick. Shouldn't be that hard to draw, like it's like an oval thing and on a leg, right? It's basically like, why do you ask me this shit? I don't care. Bruv, shut the fuck up and just like give me Inkscape. Goddamn freaking software. I hate software in 2024. Right, so I believe the software in 2024 must shut the fuck up. Right. How can I have a black background? I don't remember how to do that. Does anybody remember? So the display border guides grid color scripting metadata view box. I do not remember. There was a way to set like a black background, because this is like a flashbanging me hard. I don't want to use that. Inkscape dark background. Is there any way to do that? Because I do have it set up on my other account. Shut the fuck up. I do have it set up on my background color. So in the document properties, I probably missed that. Nah, it's not there. Oh man, I don't know. It's just like, it's so annoying. Oh, it's just like useless. Background. How to set the open document setting, pick the black background color. Am I dumb? Am I really that freaking dumb? I literally don't see where is the background color. I literally don't see that. So high color, there's nothing. I feel like I'm really fucking dumb, I can't see shit. Because I remember it's been somewhere here. It was somewhere here, but now it's just disappeared or something. Background. Ah! Oh my god, I'm an idiot. Okay, I see. The border. Alright. So the desk. Yeah, this is what. Okay, finally. That was hard. Was not obvious. Okay, page. All of that has to be black, right? So just like set all of that to black. And that's it. Don't care. So let me see. Oh my god. So actually 512, right? So in pixels. So what we can do? What the horrible color it is. All right. So can I do something like this? All right, so that's basically the mic thingy, right? So that's basically the mic thingy. Now let's have a circle, and I suppose I want to do something like this. Maybe I would like to make it thicker. So fill and stroke. It's lagging like fucking crazy. So maybe not. How about maybe 8? What about 6? Yeah, something like that. If we manage to... Yeah. Let me see. Can we snap it somehow? Is that a good way to snap it? Yeah. So one of the things we can do, we can transform that to a path. So we have these nodes that we can maybe effectively detach from each other. So we can do that. We can do that. And we already made a half of the microphone, actually, believe it or not. That's basically the microphone, isn't it? I'm pretty sure it is. Right, so I can just put that stuff in here. Boom. So now I want to put that. So the width, the thickness of this thing is 6 millimeters, and now if I try to take that and rotate that, that's the mic. Look, ma, I'm a designer. I'm a designer, ma. What the fuck? Why is it so easy? Imagine paying for icons, bruh. Cringe. Fucking cringe. Why paying for goddamn icons if you can just draw them yourself? Alright. Imagine also using generative AI to create icons. Like, it's so goddamn fucking easy. Something is wrong with you. Though there's something interesting about this. Honestly. Just a second, we have to... Oof. That looks like scheisse, meine Freunde. Why does it look so bad? Yeah, that's better. That's better, so it has to be somewhere here. Yep. Looks good, looks Gucci, looks Atamaguchi, I think so. So let me save that somewhere and see how it's gonna go. So we have somewhere in here the resources, icons. Here they are. Here they are. I'm going to save this entire shit somewhere here. Microphone. And here it is. Here is the microphone. So one of the things we have to do, so there's a command svg that goes through all the svg files and renders that. What the fuck is this copy paste, bro? So what if we just had something like this? Can I define struct svg in path out path, something like this? So yeah, nob rebuild. So we have icons. Yeah. So now I can do something like svg svgs, and I can have a bunch of them. I wonder what's the easiest way to do that. So maybe it makes sense to literally copy paste this entire fiesta and I'm just thinking what's the best way to approach that. So we can do something like this. So then we can select all of these things. It's lagging like a motherfucker. Oof, I think it accidentally removed more than required, but I don't fucking know, bro. So let's get rid of that. Why these things are empty? Why some of these things are not empty? I don't freaking know, man. I don't freaking know, man. Okay. So let's actually remove all of that stuff. So in here, we're gonna have in path, just using a little bit of a Emacs magic, then out path, like so. And then we can put boom. Can your stinky Vim do that? Can you stinky Vim do that? I don't fucking think so. Don't fucking think so, mate. Don't fucking think so. Out. So I want to align out. That looks like shit. It should have actually aligned the dot as well. There we go. Now we're fucking talking, mate. Now we're fucking talking. So what that means we can finally iterate through all of these things, like this array len svgs plus I. So now I can literally just have one thing in here. So this is the output essentially. So svgs I out path. If the out path requires the rebuild, we're gonna be rebuilding it. So this is the in path. Right, so we just do that. Background, convert, resize. Ooh, it also resizes all of that shit 256, which is interesting to say the least. But okay. In terms of, okay. Wait a second. So some of them do require a resize, some of them do not require resize. So that means we probably need to have something like resize. Right. We can try to do that. So boom, boom, boom. And in here we can say, okay, resize 256. Then here we can also say resize 256. For the rest of the things, we're going to say no resize, so it will be initialized with 0. And the thing is going to be as follow. If svgs I resize, just use the resize. Just do the resize. And here we're going to be actually doing nob temp sprintf, I suppose, right? So it's going to be d, and we're going to be just doing it like that. So the 0 resize indicates that we just don't resize, as simple as that. So this is the input, right? So svgs I in path, and this is the output. So svgs I out path. There we go. So, and in here, what it says, it just does the logging. We can do svgs I out path. So let me kill all of that stuff. So now we don't have this. We basically compressed the copy pasting effectively. We compressed the copy pasting. And then, yeah, there we go. So all of these things. They're kind of annoying, to be fair. They're too long in my opinion, so I think I kind of preferred when they were just a single line. Right. I kind of prefer that, so let's actually go back. All right, I do prefer when they are single line. Yeah. Let's align out. We might as well maybe align resize and also align this thing. Look at that beauty, meine Freunde, meine Freunde, meine Freunde. That is absolutely beautiful. Love it, love it, love it, love it. Okay, I wonder if it's going to compile. So let's try to compile that and go to the compilation errors. So it's a knob array length, right? Knob array, and it seems to be compiling. Okay, so if I try to do SVG, it tries to rebuild some of the shit, but then it fails. I have no idea why. So it tries to rebuild that with the background none. So, okay, that is weird as hell. Resource icon. So it fails at render. What the fuck am I looking at, honestly? What the fuck am I looking at? I'm thoroughly confused, actually. I'm thoroughly confused. I think I confused input and output. That's what I did. Yeah. Yes. That's basically what happened. Okay. So, but I probably fucked something up, obviously. Right, so that's totally fine. And now everything is up to date. Okay, that's pretty cool. All of these things are up to date. So something have updated. I don't know why I decided to update them, honestly. Yeah, why the fuck did it update them? Why the fuck did it update them? I'm actually not sure. But it updated some of them. Alright. Anyways, so the point of this entire stuff was that now I should be able to easily add microphone PNG, right? And it's going to be a part of the microphone SVG. So that's basically the point of this entire thing, right? So it's easy to add new things. Just easy to add new things. And if we go into the resources, into the icons, here is the microphone PNG. So this is probably something that we also need to add to the resources somewhere here. Where is the list of, yeah, there we go. So here are the resources that we're sort of packing. So microphone PNG. So that is very important. Let me try to build the whole thing. Let's take a look at the bundle. So do we have micro? Yeah, we do in fact have microphone. That's pretty cool. That's pretty cool. That's pretty cool. So now, if I go to the plug.c and try to find the toolbar, so there is a, yeah, there we go. So adapt toolbar to know which it's some sort of to do. Okay. So here are all of the buttons and shit. Here are all of the buttons and scheiße. So there is a play button, there is a render button, there is a volume slide interact and full screen button somewhere there. What's interesting is that you can notice something about these buttons is that their X is different every time. So you have X, boundary X, then the next button is hot button size 1, hot button size 2, and if you were to add another button in here, you're probably going to be offsetting by hot button size 3. Basically. So what we probably need to do, I probably want to actually add it between the render button and the volume button. So let me try to do that. I'm going to be adding it there. So let me, so somewhere between these things, right? So somewhere between them, right? Because this thing, it expands to the right and everything. So it's kind of like, yeah, you don't want to put it in front of the volume. So the position of the button is not final, right? So I just needed to put it somewhere so I don't forget that it actually exists, right? Okay. So let me see. Maybe we need to have some sort of a thing like X, which is initially like this. And then you just use this X, and every time you used it, you sort of like add HUD button size, and you basically make and like have an automatic layouting, right? So that's not a bad idea, honestly. Maybe even somewhere here, right? So you just like sort of append it to the list in here. So you add another one in here. So this is X. Right, and you just add it. So that way you can kind of shuffle them around in any order, and that is not going to break anything, I think. I think it shouldn't break anything. So let me close all of that stuff and this thing as well. I don't think it is important anymore. Let me try to rebuild the application and maybe go to the compilation errors if there's any. So, and now I'm gonna try to run this thing. Boom. So everything, the order is fine. The order is fine. So one of the things I want to do, actually, I want to enable the hot reloading. That will probably require rebuilding Raylib. But maybe, well, it's already built. I just need to build like a DLL version. Right, so that seems to be working. So if I try to do that, so I want to be able to hot reload all of that stuff. Yeah, so the idea is now, if I go here, let's find, for instance, play button and render button, and I want to switch them around, switch them places. And if I try to do that, so it's rebuilding, seems to be rebuilding. And yeah, now they're switched places, right? So we have automatic layouting, which makes it easier to actually switch things places. I don't know what the fuck is going on. All right, so let me bring it back. Okay, so that means I should be able very easily add a new button in here. Play button, render, volume. So what kind of button we're going to be doing? So let's say microphone button. We're going to be using the clitoral, right, to define sort of the slot where that button is located. Right, and I suppose this thing is going to be probably acting like any other button, right? So it's going to be returning its state. We're going to be checking the state, right, and we're going to be doing something, right? So here we have start rendering track. We can start capture or something like that. And this entire thing must be only available if Visualizer microphone is defined. Otherwise, just completely excluded, right? So it's a feature flag. Visualizer microphone. There we go. So something like that, but this thing does not exist yet. We can try to steal that from the render button, how the render button is implemented. Okay, so I feel like I want to copy paste this thing. Which means that it should be somehow abstracted away. So here is the microphone. So I can query replace a render with microphone, right? So this is microphone, and this is going to be C. The fact that the easiest way to create a new button is to copy paste this function means that it has to be an abstract function that basically accept maybe the tooltip, the microphone icon, and just does this thing automatically. So, but I don't want to spend time on that. Maybe I'm going to do that a little bit later. Anyway. And the funniest shit here is that it just compiles, right? So start capture, it can't find start capture, maybe because we probably want to define it somewhere up there. Right. So where is the start capture? So here it is. So yeah, put it here, mine it for the, okay. So we're gonna compile, please compile, I beg you. It seems to be compiling. So now we've got a microphone. What the fuck? We've got an actual microphone, and if I click on it, I can record shit, and then I press escape, and I can record shit. That was easier than I expected. What the fuck? So I don't like. The thing I don't like about this microphone is that I think the leg is too thin. I think it is a little bit too thin. So one of the things we probably want to do, we want to go into the La Resources icon microphone. So let's open that in Inkscape one more time. Of course, let's wait until it opens up this bloatware. I do like Inkscape, by the way. I do like Inkscape, but it's a little bit bloated, to be fair. Let's be honest. It's a bit bloated, like a motherfucker. Like, holy fucking shit, it's so goddamn bloated, like your mom. Okay, so I don't even know. Is that a good idea? Is it too thick? Is it too thick? We'll give it a try. Maybe it's not that thick. Right, so I'm gonna do SVG. And yeah. It didn't reload shit. So that's bizarre. Is that because it's this is because it uses the bundler. God damn. Alright, so doing that, and I should probably disable, like, unbundle everything. By the way, speaking of, some people in the comments suggested to actually support both cases. So essentially, by default, the application should look for a resource folder, and if it couldn't find the thing in the resource folder, it should, you know, load it from a bundle. So that way you don't even need to unbundle, just like always try to have a fallback as a bundle. And this is where that Boolean flag starts to make sense. Right, that Boolean flag that I said, like, the John Blow actually added, but I think it's a little bit overcomplicated. But if you use it as a fallback, it starts to make sense. So I was right. I didn't know something. All right, the complexity addition complexity was actually justified. So yeah, there you go. I'm not that good of a programmer. That good of a programmer. So maybe we'll implement the fallback. Maybe we'll implement the fallback at some point. But anyway, so let's actually take a look and see. Yeah, that looks better, honestly. Right. When you zoom in, it doesn't look that good, but when you zoom out on this sort of level, I think it looks all right. I think it looks all right. I think it looks all right. Okay, so, and now let's test this feature without the feature flag. All right, so if I go ahead and do config.h and just simply disable the microphone. I'm simply disabling the microphone. I wonder if you can hot reload with feature flags. Okay, so here, so that makes sense. So if defined mutualizer microphone, again, this is definitely has to be like abstract button. So it's begging to be factored out. It's begging to be factored out. So I'm gonna try to run that. Let's do that. And we don't have the microphone. If I press C, microphone doesn't work. This feature is completely disabled. It's not ready. I don't want to ship it even into the main source code yet, right? So because if I ship it right now, even into the main source code, a lot of people are going to be reporting issues with that. And obviously there are issues. Obviously, I know that. Right, so what do we have? Let's go ahead and enable it back. I want to test if I can hot reload this feature. I'm pretty sure, no, I won't be able to hot reload because it changes the structure of the plugin, of the data. So if I try to hot reload it, it kind of worked actually, but I think it will crash if I try to. That is bizarre that it did. Okay. So it probably works accidentally, right? It probably works accidentally because it literally changes the schema of the plugin structure. So that means it's just writing into like incorrect memory. So it's kind of dangerous, to be fair. It's kind of dangerous, right? So it's not the right thing to do. It's not the right thing to do. All right. So let me do a committee and maybe potentially even a pushy. All right. So Let's me do, yeah, so we also want to include this. So we get ignore output wave, do we? So visualize the output wave. It's one of these things that we also want to ignore. We also want to add that. So we have captcha. It's not really needed anymore, so let's remove that. Okay, that's pretty cool. So I probably need to assign some sort of a license to these icons, right? So because some people ask me whether they can use these icons in their applications. And the answer is yes, you can use them in your applications because they're too goddamn generic, right? So I don't really see any value in just like keeping them, right? If you want to use them, just use them. It would be nice if you also credit me, but you don't really have to. They're too generic, right? So they're too goddamn generic to the point that you can just draw them yourself. You saw me drawing them myself, right? It's just like the only thing you save is just like time and do that, right? So I can see that much value in these icons. So feel free to use them. Even if you credit me, that will be even better, but you don't really have to. So I should put some sort of license maybe. So common creators or whatever. Anyways, because majority of these icons are just like very simple shapes, like a few shapes. The microphone is literally like 4 shapes, like oval, the arc, and the leg is two sticks, and that's it. Right? It's just like it's too generic, too straightforward, too simple. Okay, so add microphone button. Le button. I'm gonna push that right into the repo. So microphone is cool and shit, but can we capture shit from the from the environment? Can we capture shit from the environment? That's a real question. That's a real question. I want to try to do that. So to do that, we'll probably have to enumerate the playback devices in Pulse Audio and pick the one that is the currently playing thing, right? So yeah, so we can go to YouTube and find maybe something maybe some of my videos and just like capture something from them. Tsodin daily reviewing your pull requests, hiding the date. Okay. So if I start playing sounds from this video, look, second Zozin. It's a second Zozin. Isn't that poggers? Okay, so there is a playback chromium. So there is this playback chromium. So if we try to enumerate devices with mini audio, we'll probably see chromium as one of the devices. We'll probably see it. And if we pick it, we'll be able to maybe capture this thing from from the chromium. But that's only for Linux, right? Or for systems that use Pulse Audio. On Windows, like, it's not a problem. You can just like use their API and it just captures stuff from the loopback or whatnot. Right, so let me actually see, how do you enumerate the devices? How do you enumerate the devices? So mini audio, enumerate. You can enumerate over devices to determine, okay, so you create the context. You create the context, you get, okay, so we have playback infos and count and capture infos and count. So you get the devices, loop over all of these devices and print their name. Sounds pretty straightforward, honestly. Sounds pretty straightforward. So let's go ahead and do that. I'm going to do enumerate .c, and in here we're going to include mini audio.h int main. So it's going to be void like so, and there we go. So define mini audio implementation. So we do that. Error. Okay, printf error. Maybe ma context. You know what? I probably can do some epic Shaisung. So I can. It's not really that epic. I mean, I can just take that. Printf. maybe even fprintf into std error, then error, boom. It will be better to do some sort of a description, right? But I'm too lazy right now. I'm kind of too lazy right now to do that. So let me try to build enumerate.c, and mini audio is not found, which is understandable. So let's actually try to find an src. So that should be enough. So it will probably complain about math, but that's fine. We can provide the math. I should have actually provided it right away, but whatever, because I will have to wait the second time. Okay, so enumerate. We got some stuff, right? So we got the built-in audio and the capture thingy. So this is a play. Oh, so we're iterating over the playbacks, right? But we don't look into the captures, right? Which is exactly what we want actually. So I'm gonna start playing shit, and I'm gonna run it again. And I can't see Scheiße. And what are we doing today on Twitch? So there's no playback, unfortunately, even though, So pulse audio. So output devices. Maybe I have to be in a certain group to, well, there was a built-in audio, right? So there we go, built-in audio analog stereo, right? And if I start playing in here, you can see that Chromium is at built-in audio analog stereo. So maybe that's what's going on. So maybe that's the device that we need in here. Okay, that's cool. That is very cool. And if I, right. So my device type playback, right? I create that and I just pick a specific ID. I just pick a specific ID. All right. So we can actually try already go ahead and just at least test that, right? So we don't have to really embed that into the application yet, but at least test the idea. Because I want to be able to enable like recording stuff from your system as one of the use cases. So you don't have to look for the file and then, you know, drag and drop it, right? So you're listening to some music, you want to visualize the music that is currently playing, you just press one button, just record a small chunk of it and then render that into the video. Makes it extremely fucking convenient. And because of that, I feel like the ability to drag and drop files into the application will go into sort of like into the lower priority because it's not that convenient of a feature. Because to be fair, in 2024, not that many actually people use files, music files, right? So nobody, like, do people even know about such concept as files in 2024? We're going deep, man. We're going deep, right? So the computer illiteracy is just like growing exponentially. It's fucking insane. It's like I'm in from that weird generation that had to teach their parents how to use computer, and now we have to teach our children how to use computers. Right? Our parents didn't know how to use computers because, well, the computers were new things, right? So we had to kind of teach them. And now we have to teach our children because the computers try to intentionally hide from you how they work and how to use them. Right. It's such a bizarre situation, I swear to God. Anyway, cheers. So yeah, nobody uses files in 2024. Who fucking cares about files? Who fucking cares, mate? Who fucking cares? So let's go ahead and go into the plug.c. Let's go into the plug.c. And in here, start capture, right? So we do start capture. And what do? We just pick the capture device, right? We just pick the capture device. But then, what if I just say playback device, right? So here I never had to specify the capture device. I never had to specify the capture device. Maybe I can just use the playback and it will work too. I don't fucking know. Let's give it a try. Who knows? So maybe it's as simple as that. So let me rebuild everything. Let's go here. And it crashed! Freaking crashed! That's so surprising actually. What the fuck? So in mini audio, we never specified the ID. Right. So we never specified the ID. Like, it segfaulted. It didn't even throw an error, right? It literally segfaulted. That means it was successful, but then something went wrong. We can always find out what the hell has happened by using the debugger, as usual, right? When in doubt, debug it out. Build mutualizer. Let's just run it, right? And let's just do that. Okay. So then, what happened in here? Okay, something happened in a callback. That is rather surprising, and it failed somewhere here. Like, why did you fail here? That is bizarre. So device on data inner. Right, okay. So it didn't even fail on a place which is somehow related to these things. It failed when we were trying to just visualize this thing. That is bizarre, my friend. That is absolutely bizarre. So playback. So if I do capture, right? Okay, so the debugger didn't help us. Didn't help to explain the situation. The debugger Wagga didn't help. Yeah, the microphone works, but if I do the playback, it simply segfaults in a place that is not even related to mini audio. That's absolutely bizarre, honestly. That is absolutely bizarre. Maybe because you just can't do that. I can do the playback and... Okay, let's enumerate them. Okay, so maybe I should have enumerated them. So let's go ahead and do that. So we create the context. Right, and we have to do this kind of stuff. iDevice. Right, so... And afterwards, we have to do this thing. So we have to assign the config playback. Ooh, by the way, here we're setting capture, but here they're setting playback. That is interesting. So sample. Oh, this one is interesting because there's a sample rate like that. Maybe that's the problem. Maybe I should have actually done playback instead. Maybe that's what's important here. Actually, let me try to do it like so. Right, so it's gonna be capture. So here we're doing capture, right? So as you can see, here is the capture, and here they do playback. Might as well even do something like this. Maybe is that a good idea? Who knows? We'll see. We'll see. So I can basically flip-flop between capture and playback. Though I have a feeling that playback might not be. So playback probably expects you to send the sound, right? That's probably what it expects from you. It expects you to send the sound. So I don't freaking know. So I don't know. So probably I'm not sure if we'll be successful on that one. Okay, so there's something in here. And since, okay, so I probably want to get rid of that one. It's irrelevant. It's kind of irrelevant. Yeah, it still crashes, so it's probably not how we're supposed to initialize this thing. All right, so I'll probably try to figure out a little bit later how to do the the playback thingy, right? So I can figure it out later. But definitely one of the features that we're going to have is an ability to capture stuff from the surrounding system, right? So for now, we have the microphone, right, which is sufficient enough, right? If you want to capture from this from the system, just put your microphone in front of your speakers. I'm joking, by the way. We'll figure it out. We'll figure it out. So hopefully I finally documented this feature, right? Hopefully, right? So now we have like a rudimentary support for the microphone. So off screen, I'm probably gonna work more on this kind of stuff, like smooth it out, right? Because right now it's rough around the edges. I'll try to improve the UI UX, and we'll see how it goes. So definitely gonna ship that in the next alpha release. Definitely gonna ship that. Right, that's it for today. Thanks everyone who's watching me right now. Really appreciate it. Have a good one, and I see you all on the next recreational programming session with who Mr. Azos, and love you.